Welcome back to our channel. I am Anisha, your maths faculty for class 12th. We have started solving questions of exercise 5.1 of this chapter continuity and differentiability of NCERT book. In this list of questions of exercise 5.1, we are almost done. We are completed the 29 questions. In this video, we will don't do question number 30, 31, 32, 33. We're gonna do 4 questions, right? Yeah, we're gonna do 5 questions, not 4 questions, 5 questions in this video. Let's start this video. Okay, so question number 30. So first of all, read the question carefully. What the question is telling: we have to find the value of a and b such that your function defined by this is a continuous function. So what we want to find, we have to find the value of a and b such that your function f is continuous functions. And what do you mean by continuous functions? That function should be continuous at each and every point of its domain. As you can see here, your domain is whole R. So what you want, that the function should be continuous at each and every point of the real. So by using that condition, you have to find what should be your restricted a and b. That means what I mean to be see by restricted, like what should be the condition on your a and b. That means what should be your value of a and b so that your function is continuous in its whole domain. So now as you can see, your function is defined as for x less than equals to 2, it is defined as 5, and for x greater than equals to 10, it is defined as 21, and between 2 and 10, it is defined like this. As we know that the constant functions are continuous functions, so from here, if I try to make a graph, so let's say this is 2 and this is somehow 10, and as you can see, from 10 your function is defined as 21 for y equals to 21, this is y equals to 21, and for 2 your function is defined as 5, say this is 5, this is y equals to 5 line. Okay, now what you have, your function is defined, this is line equation of line, right? Ax plus b, it is an equation of line, and your function is some line, but you want your function to be continuous, so your graph should not have a jump. So in 2 to 10 your function should be look like this, right? So you have to find a condition so there is no jump on, and as you can see, only possibilities of jump can be at x equals to 2 and x equals to 10. Otherwise, when these two conditions are satisfied, then your graph will become continuous. So from here also you can guess, you have to make your continuity better in at x equals to 2 and 10. So let's begin with that. So as you can see, for x equals to 2, first we work for x equals to 2. From this 2, if you check your continuity at 2 and 10, you will get a conditions for your a and b. So for x equals to 2, your function f of x, f of 2 is defined as 5. This is your function value. Now limit value. For limit value, your left, as you can see, your left hand limit is 5 and your right hand limit. Okay, so for what we want, limit x tends to 2 f of x. So as you can see, when you are approaching from left, you have another function, and when you are approaching from right, you have another function. I have told you many times that whenever you have whenever you have a function, that is whenever you are approaching from different sides and you are getting different functions, so you should find your limit by how find its left hand limit, find its right hand limit, and then equate them. Check it first of all that your limit exists or not. So for that, first we will find our left hand limit. As you can see, your left hand limit will be limit x tends to 2. F of x here will be 5, so your left hand limit is 5. Now this is minus. Now your right hand limit. So your right hand limit will be limit x tends to 2 positive. Your function is defined as ax plus b, and so this limit will be 2a plus b. Now what do we want? We want your function to be continuous for at 2 also, because it should be continuous in whole domain. So for f to be continuous on 2, what we want, that your limit should exist. For limit should exist, our left hand limit should be equals to right hand limit, and your this limit value should be equals to your function value. When your left hand limit and when your this limit are equal, then this equal value is nothing but your limit value. So your left hand limit is 5 and your this right hand limit is 2a plus b. Now this is the require one condition you get, name it by 1. Now as you can see also, your limit will be 5 and your function value is also 5. So here like conditions are satisfying that x is continuous at x equals to 2. Now let's move to the another. We got one relation, right? We have two variables, and till now we have one relation. For to find the value of two variable, we should have two relations, right? So let's move to another relation. So another relation will come, one will come from this point and another will come for this point, that is continuity at x equals to 10. As you can see your function, sorry, as you can see your function value f of 10 is defined as 21, right? Now your limit value, for limit value, as you can see, when x tends to 10 f of x, when you are approaching to 10 from different side, for left hand your function is defined as ax plus b, and for right hand your function is defined as 21. So from here, so here you have to do the same thing, that find your left hand limit, find your right hand limit. I will directly write, you can easily find it. Your left hand limit will be 10a plus b, and your right hand limit will be 21. So we want that the limit should be exist and it should be function value. So to limit exist, this left hand limit and right hand limit should be equal. So from here what we get, 10a plus b should be 21. From here we get this our another relation, that is relation number 2. Name this 2. Now what in one what we have, phi a, sorry, 2a, right? Not phi a, sorry. In relation 1 what we have, of 2a plus b should be 5. This is our first relation, and that is our second relation. Put the value of b from 1 to 2. That means 10a, your b is nothing but 5 minus 2a. This should be equals to 21. What I did, just put the value of b in like equation 2. So from here what we get, our 8a should equals to 16. That means our a should be equals to 2. Put the value of a in any of the relation. Let I will write the value of a in equation 1. So putting a equals to 2 and x equals to, sorry, in 1. So what we get, 2 into 2 plus b equals to 5. So from here our b value is nothing but 1. So we get both the a and b value. We are done with this question, because in this question we have to find the condition on a and b so that our function is continuous functions. Now let's move to question number 31. Question number 31 is said, in this question we have asked to show that the function f of x, which is defined as cos x square, is a continuous function. Okay. So as you can see, this function, what we have to show that okay, to show that f of x defined as cos x square is a continuous function. So as you can see, this can be written as some composition of function. Say if I take my g of x as cos x and my h of x as x square, then my g composition of h of x, this will be g of hx, that is nothing but g of x square, and g of x square will be nothing but cos x square. Now as you can see, your f of x can be written as composition of g composition h of x. Now what we gonna do, why I'm telling this composition, you can see, if we have an algebra of we have an algebra of continuity, that if my g and h are continuous at say x equals to a, and their composition is well defined at a, then g composition h is also continuous. Then your g composition h is also continuous at x equals to a. So we're going to use this. For that, what we need, we have to show that our cos x and x square are continuous functions. And as you know, the cos x is continuous, x square is also continuous. It's very trivial for you. I am not doing the h of x as continuous. H of x as equals to x square is continuous function. We know that because it is like polynomial function, and all polynomial functions are continuous functions. So I'm not doing that. You can do it by yourself. You have to show it is continuous at all domain, that here you have to show that it is continuous for any r, any real number. So it's homework for you. Now maybe I can explain that g of x equals to cos x is a continuous function. So g of x equals to cos x. For this I will explain you. So take your x as some like a real number, say C. C be some real number belongs to R. Now to check its continuity, what we want that our function value should be equals to limit value. So your function value g of C is nothing but cos C, right? Now this is function value. Let's move to its limit value. So this will be limit of x tends to C cos x. So this can be written as I have already told you in previous questions also, when you have a like to for you have to find the like trigonometric limit of some trigonometric function, you can always use to change this limit is this form, limit h tends to 0 cos of c plus h. So these two are same. You can easily see when h tends to 0, then your c plus h tends to c. Okay. So now use like a formula of cos c plus h. This will be cos c into cos h minus of sin c sin h. Now it's very easy to like apply the limit. So this will be cos c into cos 0 minus sin c into sin 0. We know that sin 0 is 0, so this will be 0 and this will be 1. So this limit will be cos c. As you can see, your function value is cos c and your limit value is also coming cos c. Your function value and limit value both are same. So from here what we get, that cos x is a continuous function in a whole domain, in whole R. So from here what we get, that h of x is also a continuous function. That is homework for you, by the way. H of x is also a continuous function and g of x is also a continuous function for any real number. So by using the algebra, that composition of for let's say for any x equals to c belongs to real composition, that is g composition h of c, like g composition h at x equals to c is also a continuous function. And we have started with an arbitrary like real number c. So by this what we get, our g composition h is a continuous, it is like is also continuous at x equals to c, and from this we conclude that g composition h is a like continuous functions. That means this is continuous at all the point of its domain. So we get it that that is nothing but that our f of x is equals to cos of x square is a continuous function. Okay, we are done. Like it's very easy, but you if you can like this is a very good question as per my knowledge, because it's like you now I can tell you by I can bet also that in previous some questions you are using the algebra of continuity, right? So algebra of a continuity is a very important part. You should like do each and every questions where you have to use your algebra of continuity, because you can have some like questions related to this in your boards also. Because why I'm telling this, I have also experience in my board also, because like algebra of a continuity is a very important topic. That's like a base for you guys. You should understand it properly. That's why you have this different type of questions, like for summation, for some for their sum, for their multiplication. Now you also see like example for the composition also. So it's a very like good topic. So let's move to next question, that is question number 32. Oh, yeah. That's what I'm telling. This was the question I have faced in my board also. So this is a very good question. So what is this telling? In this, what we have to do? To show that the function f of x is cos x is a continuous function. Okay. So here you can also think how can you make it by using a composition. Okay, same. It is same as 31. So you can see, take your g of x as cos x, your h of x as mod x. No, 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 no. Yeah, fine. I will change the composition. So you take your g of x as cos x and your h of x as mod x. Now take the composition h composition g of x. So this will be h of g of x, and this will be nothing but h of g of x is nothing but cos x, and this will be mod of cos x. As you can see, this will be nothing but your f of x. So what you have find, you can write your f of x as a composition of two functions, that is g of x and h of x. Now, same as in question number 31, you have to show that your g of x and h of x are continuous function, and you have like already shown that your h of g of x is continuous. continuous function. Now you are only left with the like your h of x, and it's a very well-known continuous function mod x. Like I will tell you here by your graph. If you like, if it is not like properly mentioned, you can directly use. But as you can see here, you have to show that it is a continuous function. So for that, you have like you need to explain your h of x to be like properly by using definition that mod x is a continuous function. But I'm not doing that because this will be a homework for you, because I have did this question in my boards. Now it's your time to do this question, it's not my time. So this is a graph of h of x equals to mod x, right? So in this graph, you don't have to lift your pen. That means this is a continuous function, and it's a well-known. I have told you in, I think, in the introduction video also. Like mod x is like, you should remember that like they are the important. I'm listing the important functions that you guys should know for, like it will be very helpful. That is sin x, cos x, mod x, mod, sorry, any type of like ax plus b, mod of ax plus b, then any polynomial function. They are the important like continuous functions that you should know. So by using this list, I am telling that h of x equals to mod x is a continuous function. Now, since both of them are continuous functions, so their composition will be a continuous function. So by this, your composition will be continuous function. So by this, your h composition g will be continuous function. By this, what you get, f will be a continuous function. Like I'm doing the rough work here. Now it's your, like it's your call to do it in your homework, because it's a very good question. Now we'll move to the next question. This is examine that sine of mod x is a continuous function. This is same as we have did for like in this all this question, you have to just guess what composition you can make. Okay, so here I am giving you the hint what composition you should make, and then the rest of the part will be homework for you. That is, in this, what you can do, take your g of x as sin x and take your h of x as mod x. Now I think you can guess how should we take the composition. So take your composition as g composition of h. As you can see, if I take my g composition h of x, so this will be g of h of x. That is nothing but g of mod x. That is nothing but sine of mod x. Yeah, this is the required our f of x. So here you also know that similarly, as you have the, like as I have proved in question 31 that cos x is a continuous function. Similarly, you can prove that sin x is a continuous function, and it's a very well-known question that well-known function mod x, which is a continuous function. As both are continuous functions, so their composition will be continuous function. So from here, what you get, your f is a continuous function. So it's homework for you. I'm not doing this. See, you like you can get now from here. I think if you want some extra question from my side, I can give you also. That is, think for 10 of mod x in the domain open interval 0 to pi by 2. Okay. And first is this, and another is I can give you 1 plus mod x, same as yeah, you can think it for like by your own, and you can change this question. This is on polar, like I am not giving, whenever you have not specified any domain, you should like consider the domain of this function. Okay, so okay, so that's all for this. So do all the homework questions, that will be very helpful for you. Do all the homework questions. If you have any doubt, just ask me in the comment sessions, and let's meet in the next video then. Till then, goodbye. Please like, share, and subscribe our videos so that you can reach to our videos can reach you to guys as soon as you want. Thank you.